everyone. This will be the first original official lecture for the foundational physics courses. And I mean, there will not be much of maths because, again, this is high school stuff. So, yeah, core idea. So, we're just going to write core idea of the chapter. Core idea of the chapter. Um, we know that physics is, measure the quantity, describe the mathematically, right? You measure some quantity and you describe them mathematically. So I'm not going to use much of iPad. So, and you know what a physical quantity is. So physical quantity is some number with some units. So if I say 5 meter per second, so I'm saying this is a physical quantity, 5 meter per second, which denotes the velocity, or if you want to say it in scalar format, then it is speed, right? Pretty much 5 meter per second speed. And which moves on to our next lecture, next step, which is the scalar and vector. So scalar is speed, scalar has only magnitude, there is no direction, like mass, for example. So mass is 3 kilograms. So it doesn't say 3 kilograms to the left. You don't say 3 kilograms to the left. You just say 3 kilograms because mass itself has no direction. It has a magnitude, definitely, but it has no direction. Or if you want to set time is 3 seconds, so time is 3 seconds. So it has 3 seconds. So you don't say 3 seconds to the left, right? That is scalar. So there is no uh, direction, there is only magnitude. Then you have vectors. Vectors have magnitude and direction. So magnitude and direction. So if I say 5 meter per second, so I can say 5 meter per second to the left. Or if I say in force, so force is also a vector quantity. One is the force of 10 Newton pushed to the right. You have a magnitude, which is the 10 Newton. You have a direction that is to the right. And the only reason you say it's vector is because depending on where you push or depending on where you apply whatever you want to apply, the sign also matters. So if I say force of 10 Newton pushed to the left, usually people would say minus 10 newtons. But if I say force of 10 Newton pushed to the right, then I'm going to say plus 10 newtons. Same thing for speed. If I say 5 meters per second to the left, then I'm saying that this is minus 5 meter per second. As in 5 meter per second to the left, in which what you say speed, we say velocity. Right? So if usually what we're going to do is in the further lectures, not in this course, probably this course, and in the further lectures, we're going to do in X, Y, and Z. You're going to have them in coordinates, and you're going to have a minus value, indicating that not meaning it doesn't mean that 5 meter per second lowered, but because it means 5 meter per second to the left, right? Or 5 meter per second wherever the direction is placed. Cool, good stuff. Moving on, then we have the SI units or the SI base unit. You have the base units like length, time, mass, right? So everything is built on length, time, and mass. So length, time, mass. If you talk about force, force is also made in terms of the length, and then you get the time, and then from length you get the velocity. From velocity you get the acceleration. But everything is made from length, time, and mass. These are the core where you derive them and then differentiate them, and which means the next thing that comes up is dv by dt. This is your velocity. So this is why you say this is meter, this is second. This is why you say your velocity is meter per second. They pretty much say that dv by dt, dr, my bad, dr by dt, dr is meter, dt is second, so meter per second. That is what you call your velocity. Cool. And then you have a little bit of prefixes, so you know that 1 kilometer is 10 to the power 3 meters, or you say 1000 meters. 1 centimeter is 10 to the power minus 2 meters. So 1 kilometer is 1000 meter. 1 centimeter 10 to the power minus 2 meter. 1 meter 100 centimeters. Cool. Basic stuff. They're not meant to be that hard. I'm actually going to move on a bit faster now. But this is the pretty much the first lecture for everything. Actually going to, so this covers section 1.1 to 1.4. The book that we're using is the University Physics with Modern Physics 15th edition. So I'm going to attach the book, don't worry. So it's University Physics with Modern Physics 15th edition. You can use that book. That's from chapter 1. Chapter 1, it's not much. It's just basic stuff, high school stuff. Probably you have done them in high school physics. But yeah, I'm not going to waste much more time. I may begin with chapter 2.